Hi, Tom here. We've gone ahead and put together an informational video blog for you. It's the next installment in a series of project updates. The project itself is moving along well and our user interface is starting to take shape. In this video we're going to demonstrate how a home energy audit is done and show you the report that it produces. Now, why are we doing a home energy audit? Well, as part of the project, we need to establish some a baseline energy profile for my home. We need that data in order to validate the data that's produced by the diagnostic system. Do they line up? And since we need to do the energy audit, we decided to video the process and share that information with you. Just a quick recap on the project itself. The purpose of the home diagnostic system is to be able to track the energy efficiency of a home's building envelope. It's sort of like how the walls, windows, and insulation are all performing to keep the heat in the winter and kind of keep the heat out in the summer. The goal of the system is we're able to present that information, that energy modeling information, to a homeowner or a service organization so that they can optimize their energy use related to heating and cooling. So, what does a homeowner do today, if they want to understand where their energy is going? Well, essentially it involves a truck roll. A professional has to come out to your home and do an energy audit, and you're going to see how that's done in a moment. But we want to change things, okay? So we want to be able to create an IoT solution that mirrors that energy audit process at a high level and present that information to the homeowner. And if we can do that at a price point that's low cost, then homeowners will be able to self-diagnose their energy consumption. And heating and cooling is typically a large expense for most homeowners and property managers. And the idea is to get this information into the hands of folks that want to improve their energy consumption, and it has huge potentials if we can do that. The obvious is to lower their monthly energy expense. They can improve the comfort of their home, but very importantly, you can lower the home's carbon footprint. So we've attached the energy audit report to this video blog, so if you like, you can check that out. The link will be below. And so at this time, let's check out how an energy audit is done, and let's get some baseline data for the project.
Hi there. Today we're going to be doing an energy audit on this home, which is going to involve an air infiltration test using the blower door system, and also a heat load calculation where we'll have to calculate the volume of the home for our calculations. Okay, we're going to begin the blower door test by installing the blower door, which is a large frame that goes in an exterior door. It consists of a large fan with multiple rings so that we can control the amount of air that's flowing in or out of the building. It's controlled by a manometer. The manometer then is connected up to the blower door, and it's also connected up to a tablet computer that controls the manometer, controls the flow that's happening between the inside and the outside of the home. These tests are all, the software I should say, is written by the hardware manufacturer, so you get the best possible results. We begin the test at 50 pascals, which in real terms means about a 30-mile-an-hour wind hitting your house at all angles at the same time, something that doesn't happen in nature. And then we're going to decrease it down by 5 miles per hour per test, so we get 6 to 8 valiant points, bring it down to about 15 miles an hour, I guess, at the end, so that we can take these values and make sure the home is performing the same at all different levels. We're going to put this into our package, and it'll become part of our report to the homeowner when we're done. Okay, according to our blower door test, Tom has a very tight home. The air exchange, or ACH 50, that we just measured came in at less than 3, which in my experience in doing thousands of these assessments, anywhere from 4 to 20 is where they range. Tom is sub 3, so he's done very well. That means his house experiences 3 air exchanges per hour on an average. So that is all very good, and congratulations for Tom to doing the weatherization and tightening things up and building a nice tight house. And further to Tom's testing, he has an estimated leakage area of about 30 square inches. So this means if we added up all the cracks and all the air leakage in his home, it would add up to a 10 by 3, about the size of this tablet that he has as air leakage, which again is very, very good. Good job, Tom. Okay, so now that we have our blower door data, we're going to do a heat load calculation. And this will consist of a number of things, but first of all we're going to have to calculate the volume of the home. This is the living space of the home, which will include the main floors and the basements. This data will be combined with the blower door data and put into a modeling package called HOT 2000. HOT 2000 is a package written by Natural Resources Canada and is considered an industry standard for doing modeling of homes. Once we've got the data into HOT 2000, it'll generate a report which we can give to the homeowner for their perusal, and as well we're going to attach a copy here onto this video so that you can take a look at it as well.
Okay, that concludes our informational video. I hope you found that interesting. So now you can see what it takes to do an energy audit. And we've got our baseline data for the project. And don't forget to check out our video blog, and we'll see you in the next video.